Alright, so this problem at first looks kind of weird. You got two circles, and then you got a random line, drawn as E, and then you read the problem, and then you realize what the problem is actually asking. So it says in the figure above, the two circles are tangent at point E, not line E. So this is not actually a line. The diagram is just drawn really badly. I mean, that line is sort of thinner than the other one, but yeah, don't get messed up by that. It says at E, and the length of GE is 16. So line segment GE is 16, let's label that. If the circumference of circle with center G is 4 times the circumference of the circle with center D, what is the length of ED? So basically, we know the radius of circle G, and we're trying to find the distance, or I guess the line segment DE, which also just happens to be the radius of circle D. So because we know the radius of this guy, what we can do is just plug it into the circumference equation, which is 2 pi r. 2 pi r. So then we can just do 2 pi times, that is wonky pi, whatever, times 16. So that gives us a circumference value of 32 pi. So that is the circumference value of circle G, but we need to find the length of ED, otherwise the radius of circle D. So what we can do is just size this down to find the circumference of circle D, right? So we can just divide this by 4, because it's given in the problem here. And so 32 pi over 4 is just 8 pi. So now we have the value, the circumference value of circle D. And so we need to reverse engineer this entire problem with the circumference equation. So now we know what the circumference is. Set this equal into pi r. So now we can actually solve for the radius of circle D, which is just going to be 4, because 4 times 2 pi is 8 pi. Therefore, looking at our answer choices, it will be D.